The paper of the day is In-Memory Performance for Big Data. In summary, the buffer pool in a traditional database management system enables efficient data access and data manipulation for databases larger than memory as well as transactional updates with write-ahead logging. However, when the working set fits in memory, the performance overhead of a traditional buffer pool is so large that it motivates in-memory databases, whose principal value is that they do not use a buffer pool. Some recent work has addressed in-memory database systems with working sets slightly larger than memory. These approaches have relied on virtual memory, compression, and offline analysis of hot and cold data items in order to improve the ability of the working dataset to fit in memory. In contrast, our pointer sizzling approach simply eliminates most buffer pool overheads. Paper prototype implementation adds metadata to buffer pool frame descriptors without impacting actual data page contents, which simplifies the task of unswizzling. An index structure with only a single pointer per node simplifies both swizzling a pointer to an in-memory address and unswizzling a pointer, and also greatly simplifies the mechanisms involved in selecting a page for replacement in the buffer pool. Paper implemented a prototype of the swizzling and unswizzling of page identifiers in the context of the show-empty experimental database system. Their hypothesis is that swizzling B-tree page identifiers alleviates the performance overhead imposed by the buffer pool and allows a traditional database to match the performance of an in-memory system that has no buffer pool. The experiment runs the standard TPCC benchmark. They compare the throughput of their database engine with a traditional buffer pool, with a swizzling buffer pool, and without a buffer pool. Now let's look at the contributions of the paper. There are 4 key contributions. First, introduction of a pointer swizzling in database buffer pool management, specification and analysis of swizzling and unswizzling techniques for the specific case of B-tree indexes, victim selection, guiding eviction and unswizzling of B-tree pages from the buffer pool. Experimental proof that these simple techniques enable a database with a buffer pool to achieve in-memory database performance when the working set fits in memory, and furthermore, achieve a continuum with graceful degradation as the working set size exceeds the memory size. Now let's talk PS score for this paper. Overall, this paper is a decent read, so it gets 9 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. It's an analysis of an existing system with pretty good description, so that makes it 9 out of 10. Its industry value and learning meter is pretty high, so it gets 9 out of 10 on each, with overall PS score of 9 out of 10.